The first program, like this is first of something, so the first program I wrote with Elixir was a little program that converted output from our time registration system into things that was fed into Excel to calculate the monthly total of expenditure on research projects. Exactly. So I thought maybe not talk about the first program I wrote in Elixir and go a different route. And then just for the faint of heart, I will be saying things, if this doesn't follow, I'll try to stand still. I will use the word Java, and I will use the word Python, possibly, through the talk at some points, and I may not be as kind to them as proponents of those religions are. So I warn you up front, there might be things coming. Good. So, first thing, this is how Java and Python programs react to you when you say that there might be something else you could use. and since I go around and I end up talking at numerous Java conferences, I get used to this. The thing is, you should have an open mind. The thing that surprised me was, at some point we had a discussion on the Erlang questions mailing list, a very friendly place, and I had the audacity to suggest using Elixir to teach the wonders of the Erlang VM, the Beam, to kids. Ooh. Erlangers. so Erlangers turned into these raving orcs. And still when I meet some of them around the Erlang conference, it's like, why are you talking about this Elixir thing? So I think, just as a word of warning, you're now fresh, you're coming into the Elixir community, we're building it. Let's not go down that route. Let's stay open. If some weird fellow comes along and says, I think I can improve upon Elixir, we embrace it. Zen moment and all that. So please be open. And then comes to the something where Joe and I slightly differ on semantics there. I think syntax is irrelevant. There's obviously hideously bad syntax, like Roman numerals, not good for things. You can also take Egyptian fractions. They insisted on only using pure fractions. So if you had to write something like, say, 5/6, you'd use the symbol for 2/3 and then 1/6, and you have 5/6, which means you have horrendously long fractions. But that notation died out. Apart from bad syntax is irrelevant. Every time you meet a person that starts arguing over, this is particularly relevant when you're talking about Erlang, which you have to do a bit of anyway when you're doing Elixir. If they start talking about syntax, that's a person not willing to change. Have fun with them, and then move on. They're not worth waiting on. But it is important, thinking. Thinking is everything. It's how you think. That's all that matters. So if you think like an old person and you come to the Beam, you need to change your thinking. That's the most important thing. And that is because language shapes thinking. And now we're not talking about a programming language, but the concepts and things you have in those programming languages. That is how that shapes your thinking. And that means at the end of the day, language is everything. And now we can just take these 3 slides and confuse the hell out of anybody that hasn't had the time to think about this. But language is everything. But it's the language of concepts and how we put things together that's really important. Not semicolons over do end or whatever. Not relevant. Just zero. So, now we'll get back to my journey with Lego Mindstorms. How many of you do have a Lego Mindstorms set? 7 or 8. 9. Good. Joe has one too. Good. So, my first encounter with Lego Mindstorms was in 2008. And as you can see, I was not a happy trooper. I went to Billund. I can remember it because my wife was pregnant with our second child and had my son. And we said, we'll just go in and try this Lego Mindstorm thing. They have this room in here. We can just try it. We'll just try it. We'll not buy anything. So we go in there and they have a wonderful environment and everything, and we program a robot. My son is like, he's 6.5 at that point, and we're having fun. So I run out into the shop and I buy a set of Lego Mindstorms. And I had to sneak it past the wife and all that, so you know how that this. Then we come home, and it turns out that the environment you had in that lab was a special one that made it easy to work with this. And then you're thrown into this LabVIEW thing, which was created to generate automated process control of atomic reactors or something. And you're just sitting there with your 6.5-year-old, and you're just both of you staring at the screen. What's going on? I can't use this. So, I had to sell that set of Lego Mindstorms. I'm sorry, I didn't have time to work. Unfortunately, I sold it with a profit. So, I'm an engineer, so I do smart things. So, time passes, my son grows older, and then he starts expressing out of his own will, I promise you, out of his own will, a desire to have a Lego Mindstorm set. Yeah, so it crossed my heart, hope to die, all that own will. So, we get one for Christmas 2013. And then this experience happens. We get into the visual environment, and it's the same shite. Sorry, said this word. All these things, and you take something, oh, that's a visual environment, read the documentation from it, and you drag it into your environment, and then now do something extra with it. And it turns out that there was another little thing further down that will work together with the thing you thought about, because the other one had some internal boom, boom, boom that it did. And you're just sitting there. So we shelved the rather expensively bought Mindstorms, and was just sitting there for a year. Christmas 2014. I get annoyed with having bought my son something, so I just tell my wife, my private time this Christmas is hacking Elixir on Lego Mindstorms. So, it works like this. That's me in my lab trying to do things, and it actually carried over from Christmas into this year there. And I started hacking things up and putting a library together, and that meant we were actually getting closer to something, because my son said, after I'd written some code, I can understand this code. Oy, lovely. So, and then he started trying, and I told him, try writing a few functions. He wrote something. Everything broke. So my conclusion of this was, Elixir fits when you can program a bit. So I still have my Lego Mindstorm shelved there in terms of helping my son, but we'll get back to that. There will not be a time lapse here and going back in future or whatever, but we'll then return to the teaching of Elixir in a bit. So Elixir on the EV3, fortunately, Elixir is here, and we have these guys, crazy guys, that are putting Linux on an SD card, you yank it into your Mindstorms, and it's booting in Linux. Ooh, life is good. Then you open up your SSH into the thing, you do an install of Erlang, which is just apt-get install Erlang. Can't remember whether it's a capital E or not. You'll get a warning on the command line, don't worry. But there. And then you unzip the precompiled Elixir, and voila, you have Elixir on Mindstorms. Which is good. This is something that's doable even for a, dare I say it, after all these years of working in management, not so technical guy anymore. So this is doable. So anybody should be able to do it. Basically, it's the message here. Now, of course, you need to do some Alchemy. And this is Mindstorms, because you get a file-based interface to everything you hook into the brick there. Put a wire in and put a motor in, and then it shows up as a device in sys class, tacho motor, and then it'll be motor 0. If you take it out and you put it in, it becomes motor 1. Ah, nice. And it generates a lot of files. This is what you get after you put in a motor. All these files are things you can do something with. And you're just sitting there the first time, what? What am I supposed to do with this? Most of it is documented. Because these are enthusiasts doing things, they actually document what they do. So this is good, so you can go in and understand things. So if you want a motor to run, you go in and you take the duty cycle SP file, and you write a number between minus 100 and plus 100, depending on if you want the motor to go forward or backward. Very easy. And then you write a 1 to the run file, and it starts running. Which is kind of nice. However, you're just doing this in the command line. So you're sitting there and you're catting stuff and you're reading stuff and you're, not optimal for things. So we do all these things in Elixir. We start writing a base library and get things in there. And then you can see, if we go back one slide, there's a lot of things you need to cover in your library. And lots of these things are simple reads from a file and simple writes to a file. This sounds like tedious work, and it is. So, enter a good reason for actually using macros. Yeah, this is the only sane reason for using macros so far I've seen. So, careful, because there are other bits in the code, and you can see the link where there's been a little overdoing of macros. So, be careful, use them. Yeah. So here I can define a motor property run, and it's writable, and it has a min and a max value. Ching! Good. We have a motor product duty cycle, it's writable, nope, you can read what it's doing. And you have a stop mode, and then it's writable, and you can set it to a number of different things. So, and then the list goes on for all these things you have there. So that's basically us. I've not done the library myself. There I've just worked with the guy that did most of it. And reading the documentation and writing up these def motor property with whatever is in the documentation so that it fits. And then you have access to these things. And then you also have some things like reading the values is actually quite nice, because then you have a get function name, which is then the name of whatever thing you want to, for say, in the duty cycle. Then you do some checking here, make sure you get a full file name out, you do a read with a utility function, and then you turn the value you read into a string on integer or atom, a string into an integer or atom, and then you're done. And then this macro expansion, blah, 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 works, and then you have all these things available to program. So that means we can actually do something. So here I'm telling the motors to go forward with different speeds, and you can see just atoms here to signify which port they're on. By the way, don't put the motors on the input ports. It just gives weird things in the shell when you start looking at what's registered there. And then you can do a color sensor here, get the color, and then some parameters too, and then you have color. This is wonderful. This is what you want. I'm in a language I like and love, and I can just write simple things to connect to my Lego Mindstorms stuff. So that makes me like this. A very, very happy trooper. You're just smiling when you get to this stage. Okay, then you're probably going, show me some Lego. And you'll be looking at me, where did he hide the Lego? In fact, I'm a chicken. I do not do live stuff when I do presentations. Simply not. But what I will do is I will show you a video. And let's see if we can get this puppy to show. Is it coming? It's not coming. Let's see if we play it, if it starts magically showing up. No, I'm the only one who can see it, and I've seen it before, so that doesn't. 1 second. That's not fun for you guys. So, arrangement, we just do mirror displays. There we go, and so, there you can see it. And this is my Swedish colleague, Jimmy Söger. That's not him, right? That's a creation he did with Lego Mindstorm. And as you can see, I don't think he's an engineer. I think he's a computer scientist. He's way more creative than me. I'm just an engineer. I wouldn't do the wings and all that, but he did it all nice, and you can see everything here look nice. So he wrote out some nice squiggly lines for the robot to follow. And anybody that knows Swedish really well, don't listen while they talk here. So. That's Jimmy talking, by the way. So it's actually working quite well. We'll see the challenge it gets to down here at the bottom. Look at it, it's following the left side of the line, and then, we found it again. And then it goes backwards. And then we'll not do what I did when I was testing this video and everything. I actually did it fast backwards with the audio on, and it sounds like they're speaking Spanish or something. So there's probably a hidden message in the Swedish they're saying. So, good. Good. So, sorry, I'm a chicken. You can come and flog me afterwards. It's okay. The door's open. There. Good. So the naive approach to these things. So now we have a thing here, it's actually running Elixir and everything. So the naive approach to doing this would be, you have one process that's a controller, that does everything. It has a timer that ticks and tells it every time it needs to read the sensors, and then it changes the motor settings by using the library we have there. That's, however, the naive approach, because there's no leverage of processes. You should be using processes, because if you're not using processes, you're having a bad fit. You might as well code this in Python. Yeah. The thought of that, right? Or C, or C++, or even worse, you could code this in Java. There would be no conceptual gain here. So we need to do something about this. So we need to think about this, the golden trinity of Erlang. And of course, I'm an ordained Erlang priest, so I'm allowed to go around and showing this one off there. This is actually something that you, as Elixir or alchemists, have to keep in mind as well. This is the divine intervention that hit Joe and the team at the computer science lab. This is like it comes from above. This is the wonders of the beam. Hallelujah. This is what you need to think about. And it happened, somebody asked me, what would they have to take away from Erlang for you to stop using it? And then you take a walk when you do these things. Never think in front of your computer. People that are thinking in front of their computer are not thinking. Period. So take a walk there. So I took a good long walk and I ended up saying, if you take these three things out, just either of them, I'm done with Erlang. And by transitivity, I'd be done with Elixir as well. You need to have share nothing. Any system where you don't have it with lightweight processes and message passing is going to cause you to lose sanity. Or you become into one of those Java enterprise programmers that are just like zombies going to work every day. You don't want to go there. You combine this with fail fast. You need to be really, really aggressive in your code. If you're trying to catch exceptions, please go back to Java. Enjoy pages of exception handling that went wrong and make a career out of that. Don't do it in Erlang or Elixir. Fail fast. Whenever something happens, you have to be Japanese about it. You bring out your knife and you do a seppuku. Die instantly. You do not deserve to live. Period. Fail fast. This is, of course, sometimes an issue there. And career advice. If you're trying to move things that uses these things of fail fast or we let it crash, don't do what I did at Motorola. We did police radio systems there. And we did a little gateway in Erlang. And we ran around in the hallways with these conscious people that knew that these radios had to work all times because otherwise police officers would be shot without having their radio. Don't say let it crash. It is not good for your career opportunities. Pick your words. So then we come to failure handling. That is the golden thing you need to add to recover from fail fast. Without proper failure handling, this approach of failing fast will not work. And it's the combination of these things that makes Erlang and thereby Elixir golden. Really important. So if you're not leveraging this in your programs when you get beyond the let's go have fun and learn the thing, you have to think about if Python is not your thing. That means you go back and you start applying this because you don't want to go to Python. There. Good. So, what we do in this thing is, you do some proxies for the sensors. So have a process for each sensor. So when you want to talk to a sensor, you go through a process. And then the reading time of reading that particular sensor is inside that process. It's not in your main loop for reading the sensor. And then whenever you have a change in value, you send a message back to the controller process. That's one way of doing it. This is a good fit. Good fit. Because you're using processes and you're using message passing. We'll stay away from the fail fast and failure handling at this stage. Let's just focus on these things first. There. So here we have a color sensor. So the first thing you do is, you call down the raw library thing there, you read the color, You do some blah, 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 to figure out if the value has changed or if it's just not just a jitter thing. Then you tell the controller, send a message to it, and then you repeat by sending yourself a check message, which is the one you're actually reacting to there in the first place. Now, this is nice. This is just one process doing one simple job, and whenever it detects something, it sends a message to those that are interested in knowing that the color it's reading has changed. Event-driven. Wonderful. What's not to like? So, then the bumper is the same thing. You read the sensor, check if it's pressed, you tell the controller, and you repeat. Nice and easy code. And I can have these two things coexisting. They're just two separate processes. And as Sasha was so eloquently explaining early on, they do not share anything. Meaning I can just separate the two things. I don't have to have all of this in one big humongous thing that's trying to read all sensors and detecting which one was read and then do something even more horrendous. Separation of concerns. This is what you have to do with processes. Use lots of them. You can almost never use too many processes. And if you want to see how to go berserk with processes, go to my GitHub account, look for my Game of Life implementation in Erlang. I'm using a process for each cell in the Game of Life thing, and it rocks. Period. Just go have fun with it. Yeah. So now the architecture, and this is where it's becoming slightly more interesting, because you need to be able to talk to other people what you're doing. And just telling people it's in the source. It works a bit of the time, but sometimes you need to talk to people that are not really able to go to them. And also you need to be able to reason with yourself at some point. So you have the color sensor, that's a process, you have the controller, and we send messages of that form there. Show me somebody that doesn't understand this, and you've shown me a manager. So, there you go. Simple test. Yeah. Then the controller talks to the motors there by sending in commands to do stuff. Very, very simple. And notice here, the notation here, here's a process, here's some message passing. Same concepts as we have in the language, Erlang or Elixir. This is the basic things, the basic building blocks. It's in my architecture. Small semantic gap, happiness. This is what makes people, not so much in Elixir world yet, because we don't have that many people, that over time, Erlangers are very happy people. Because the semantic gap between the problems they're solving and what they have on an architectural level and the domains they're solving problems in is very small. It allows you to move really, really fast. So you get feedback fast, you get things done. And actually, most people like to do things when they go to work. If they don't like to do things, they'll end up being a Java enterprise programmer, because you'd end up never doing anything. So, and then, conceptually, yes, I checked the code of conduct. I'm allowed to do this. So, good. And then you just add the bumper. Look how easy it is, especially because it's just a drawing. Just add a bumper, and it sends bumper hit messages to the controller. Again, if you can't understand this, yeah, you know where it's going. So this is actually nice. So we have an architecture here, and of course, then if I then tell you the code is really, really ugly, it sort of loses the importance. So let's look at just slight bits of the code. So the line follower here, as I told you, it follows the left edge of the line, which means you cannot have an ultra thin line, because the color sensor is like this, so the line has to be thicker than that. Yeah. Of course, implemented as a GenFSM, you'll see that. And then you have very, very small functions that does some specific operations on the motor to make it easier to do. So let's see. Here we have the state machine. And first here is the initial function going into on the left side. So when you're on the left side of the line, you need to turn slightly right. So of course we have a little function that's called forward slightly right. This is what functional programming would do for you, and also same programming things. And then you say the next state is, I'm on the left state, and now you know we've told the motor to go slightly right. So at some point you will meet the line. You'll cross being on the left side and actually be on the line there. And then when you are in on the left side and you get a color in, If it's the target color you're looking for, that's the line color of the line, then you know that you're on the right side of the left edge of the line. It's okay. I looked the same when Jimmy presented this to me. Just, what? You're following the left side of the line? Yeah. Think about it for a while. And then you also have a timeout. If a timeout happens, you keep turning this light right, and you don't meet a line, you're lost. So stop when lost, and then you do a stop here, and then it's stop, normal, and you give up. Which is the same thing to do. It's actually the same things they're doing in trains. If they don't know what to do, they stop. Which is a good safety precaution. It's not like, I don't know what to do, hit the speeder. That's not, so that's just, there's some safety critical stuff in here in Lego Mindstorms, so that's good. So, and then we have all state events. And this is if you get in a bumper hit, so you're bumping into something. Somebody put something on your path. Stop motors and event generators, you're taking down everything and then you do a stop. And also if you're getting a stop message in, which is somebody from the outside, stop this thing, I don't want to see you running anymore. So this is how you can mix in the all state events and then do these things. Nice and easy, and you have this like bumper hit, it will sit on top of all events coming in, whatever state you're in. If you get a bumper hit, you stop. So that's nice. Separation of concerns makes the code easy to understand. Good. So niceties of this is you actually get protection of the hardware by having that process there, but it's not in the library right now. And one of the things you have to think about there, if you take a motor and you tell it to go forward, backward, at some point mechanical things will break. Computer programs like going back and forth. They're made for that. If they can't handle that, they're written in Python. So there, you can add these things, and that's an important thing when you're dealing with anything in the real world. You need to be able to protect the real world from insanities of the programmer. And trust me, you're programmers, so you will do insane things. I've done it. I did test system at Motorola, where I took one radio, moved it from one place in the world, which in the real world could move it over 500 kilometers in 1 millisecond, and immediately after moving it, I took it back another 500 kilometers, and for some reason the system didn't like that. So I had to put protection for my own stupidity into my testing system. So it's the same thing here, we will all do stupid things. Put some protection into, especially heavy expensive gear. Like the Lego Mindstorms, you don't want to be frying it because you're just doing weird stuff on it. The reaction to the bumper, easy, and then you can have this smoothing of sensor readings, because as us programmers, all in programming is black and white. A value is a value, but the minute you take some sensor there and you put it on something, and there's light coming in from the sides and everything, it will not read the color the same way all the time. So you need to smoothen out these values. But that's actually done inside these processes. Now, that's okay, so I've taken this, I've put Elixir on the Mindstorms, and I'm SSHing into it. You can actually also do another thing. You can have the normal software on the EV3, and then you can send direct commands from your computer to it and control it. So you don't need to do all this moving files over from where you've edited them on your own machine, copy it over to the SD card and put it in and all that. You can just do it over Bluetooth and Wi-Fi with these direct commands. So you have things like here, output stop has an opcode. Now we're getting down to hardware. This is where Erlang also shines. This is fun. And you have different things here you can specify. And then the direct commands, they have a command encoding. And when I saw this in the documentation, I was talking to some guys that were doing these things in Java, and I looked at this one and I just started smiling. This is awesome, because this is something we can do really, really nice in Elixir. And the Java people are like, no, this is scary stuff. We have like 10 classes trying to implement this. Okay. So after that, then I went to see some of them. I had three hours on the train, and I got most of this done in Elixir. We can see some of it. So here, when I do the encoding of the thing we had there before, we have command type, the command itself, which is a binary created somewhere. some encode defaults, merge them in with the default options, the options coming in, and then you take the message counter, which is something you need to send it a number, because if you want a reply back, you can see that it's the reply to the message with the number you send it there, and some allocation stuff there, local and global, don't worry about that. And here's the beauty. This is like, that's not the full thing, but that's like 4 or 5 Java classes here. So you just say, the byte size of this, you need to know the size up front when you're sending these direct commands. It's just the size of the command plus 5, because there's a header here. For the message counter has to go into a little engine encoded 2-byte thing. Then you have the command type, size 8, global, doom, 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 doom. Easy. And you can actually understand it. So you can look at the specification for this, you look at this code and you go, I'm doing the right thing. So you don't need to write 10,000 Java JUnit test cases to prove that you've done it right. This just works. Happiness. Same thing goes for the parameter encoding. So here we have one thing that says, if the value is relatively small, I'll use the LC0 function, and that puts in a short format thing of size 1. Look at this. We're down at the bit level. And we don't care. We just, oh, there's 1 bit, we'll have to set it. And we'll have to do it in a sensible way. Go home and do that in whatever other language. So do it in C. Just for the fun of it. Brush off your Kernighan and Richter book and try to do these bit manipulations in C. And after that, you check your head to see if you haven't pulled all your hair out. So, there. And then you have another one here. Now it's not a short format. That's when it's in up to 128. Put a long format in. Say it's a constant the value thing here. Put a 0 in for good measure. Can't remember why. It's in the documentation. And then something there, and then the value itself down here. Voila. And it goes on. Nice and easy. Again, short semantic, a small semantic gap. So between your documentation and your code, the gap is very small, so you can avoid writing too much documentation. So you can focus on the real bits, solving the problem, and not writing a class hierarchy consisting of 10 classes with multiple inheritance and what have you. So, beautiful thing. One of the things to use when you want to convince somebody, say a manager, about using Elixir or Erlang for something. This is dead easy. Bluetooth issues. So we had fun doing this, and we asked the program, had the same program running now on our own machine, and then communicate with Bluetooth to the Mindstorm thing, and we just say, now we'll just follow the line. Unfortunately, there's a bit of Bluetooth latency on the Lego Mindstorm. Not just a little bit, but it grows. When you send it too much, and actually the funny thing is, you send it a message, you wait for the reply, you send another message, wait for a reply, and the latency just goes up. Just, what? I don't know what they did in the coding there. And the thing is, and I don't have a video of this because it's like the same thing, if one of your friends is really, really drunk, you shouldn't take a video and post it somewhere. It's not fair, because the robot was like, it was all over the place, and it was just trying to follow the line. It just didn't work due to this latency, so that was really terrible there. It might work over Wi-Fi. I have not yet to test this one there, because I managed to buy the only Wi-Fi dongle that works with the EV3, but it needs a Windows machine to be configured. Yeah, there you go. The world is not perfect. So anyway, so that's something there. And that's, if people want to play with this, just ping me a mail and we can talk about how to fix this problem. And the library here, that's the man. That's Jimmy. He's the guy that I had the idea for this, did some initial stuff, and then he took my initial utterly stupid ramblings and he just ran with it, and he generated these 2 libraries. So you have the full library here that you yank on to the Linux thing and you run it, and then you have the direct commands here where you can do some Bluetooth things and put that in and try communicating with that. That one will be changed to do something with Wi-Fi, because I think that has lower latency than the Bluetooth, hopefully. Because I just like the idea of code stuff on my machine, have the program running there, and then the Mindstorm robot just does things without having to copy files over and all that. And that, of course, means that I'll take credit for the idea. All problems, Jimmy. So just spam him if it's not working. So now we come back to teaching programming, because I had an issue here. I have a library. I'm a programmer. I can use the library. All good. My son started typing some Elixir and he had experience with Lua, I think, before, and he was just doing typos and everything, and then he got these wonderful error messages, which are better in Elixir, but it's not like for a 13-year-old kid to go, whoa, I understand and I dig this error message, so now I can just debug my stuff. No, we're still not there. So I need to teach him some programming, because the visual environment, very difficult. Anybody who's tried it here? Has anybody tried doing that or just went straight to hacking? Anybody used the lab view on the Lego? Nobody did. You just bought the Mindstorms and had it sitting there? Okay, fair enough. Trust me, it's very, very difficult to do that. With this one, better, but you have to learn Elixir first. So how do we solve this problem? Well, you eat your own dog food. So I'm teaching now. I'm teaching for free at my son's school. I'm teaching them Elixir. The class is called Junior Beamster. And it's everything I do is available for free at beamster.org/JB for Junior Beamster. I'm trying to, and there's a Google group so you can come and you can follow along, and I'll try to post my lessons learned from everything. But so far, you'll be surprised here, because you have forgotten what it means not to be a native iPad person or tablet person. These young people, they are native with that, not computer people. So what I had from the initial learnings is using the command line. What's the command line? And you're just standing there, shit, there goes my first lecture. you just need to bring them in, and I haven't been using a Windows machine for like ages, so how do you start a command line in Windows? So luckily they were out of their comfort zone, and I was like, oh, I'm out of my comfort zone, I don't know how Windows works anymore. So we found it's a Windows R, by the way, and you can write CMD and then you get the command line. But that's alien. And going between drives, what is that? Changing into a directory. So these are things that they don't have anymore. They don't have the luxury of somebody like me. I started my programming days on a week 20. With a massive 3,483 bytes of memory. Amazing stuff you can do with that, and you're straight into the command line and you're just hacking stuff. You get used to that. But they're born on a tablet. So that's the third thing. So you have to keep that in mind if you start doing this with kids. Their editor, it's a different experience for them. When you say editor to them, they think, oh, you mean Word? No, I don't mean Word. Because the first time some of them were just opening up Word to start editing Elixir programs. That is not super optimal. So there's something there. So you need to bring that across as well. Functions, however, are easy. They get that. And especially if you present it to them in saying, here's something you know from mathematics, let's translate this to Elixir. And then, oh, so that's how you do it. That actually works. So functions are good. Try doing the same thing with objects. And bring some Kleenex because they will be crying there. And then recursion, it comes along slowly. Not this week, but last week I went, hey, let's do some recursive functions. That was a bit steep. I had they looked like I was presenting object-oriented stuff to them, so I just reverted from that. I did my apologies and said, we'll take that in small bits. But they can actually start to appreciate some of the thinking that goes into recursive functions. So it comes along slowly. Functions is a good starting point there. So I'll continue to write something on the Google group. I have on this one. You're welcome to read in there, ask questions, how to use the material, and if there are things missing, just tell me, and I can help you run this class in your own neighborhood there. And by the way, it's not complete yet. I'm doing it every week as I do it, so I haven't got like 20 weeks of curriculum yet. So people butting in would be nice. So a new visual language. So now, good, you're not turning into orcs, thank you. We'll do that. So, thought experiment. So if you release all your tension of your daily work, and now you go on a little dream voyage with me. You will start in a nice visual environment, maybe some drag and drop and things like that. You open up the boxes as you become more familiar with the things, and you can see what's inside the box. You have the same concepts from the early environment until the day you do something really cool, which means you're coding everything in text. So I have this nice environment where I can just do things. This sounds like a good environment to be in. Well, I think so because I dreamed up the environment. So it's my dream. You can wake me up after the talk. So, Scratch, they actually do something similar. So they have these very intuitive, at least, things in their nice environment. These intuitive blocks where you can just drag them in and you can do things and all these wonderful things. It's intuitive for sequential imperative programming. So that's like swearing in the Church of Erlang. Sequentially, not sequential, but at least imperative programming. This is like for loops and what have you. So, but the environment is nice and it's easy to understand. So what if we take the Elixir thing here? Good concept for robots. So I'm thinking about the Mindstorm thing here again. We have processes and message passing, they fit the domain, we get a good architecture, maybe we can do something. So see, the visual elements in this one should be each sensor, actuator, just a process. The wires you have from whatever you have into the brick, the controller, equals some sort of communication line. So you can see this is what it should look like. Of course, somebody with proper design skills would actually draw a color sensor here and do some things here and have them look like a real wire, because this can obviously not work in any marketing department. But you get the idea, it's a concept that has to be there. And then you can just have basic implementations for these things. The controller will have a basic implementation that does something, of course, utterly stupid, but at least it does something when you connect things to it. So they come with the default behavior. And then you open up the box there, and you can see what's inside of it. So here we have a, I can't remember what D is for, but you have an initial state you receive from the input port into a variable called distance. So you need to visualize that this is done like nice, like Scratch, not my handwriting. Then you send 1 divided by the distance to the output port, and your next state is just going back to the initial state you started in. So you get an environment, and you can just open up the boxes as you become more familiar, and you can change the code in there when you know a bit more about the coding. So this is the environment I would like to create. It will happen when they instigate the 48-hour day, so that there will be more time to actually do these things. It takes time to do these things, but I think it would be really cool to work with somebody on this. Then for the learning curve, the very simple visual environment, and you can have something that's more simple than what you have today in Mindstorms. You hit a ceiling very fast. If you go in and try any sort of visual environment things, you go, ooh, this is fun. I can't do advanced things. So you just capped off there, and you left, where do I go next? There. So you can take the complex one that slips with the Lego Mindstorms, and you'll have an insane learning curve. I would like to see how the brain of those people that actually use that environment are having fun with it. I would like to see how those people look and how their brain works. Because my brain doesn't work like that. It's just, I don't get it. And then you have the same concepts from start to end. You start out in the visual environment where you have processes, message passing, these building blocks, and then hopefully you'll get a smooth learning experience. So if anybody knows somebody that wants to do a master thesis project or something, here's a cool idea. And it'll earn me some street credit for doing something with Lego. It always does. It works wonders if you're in a bar. Oh, I do Lego Mindstorms. You get all the talk, all night. Plus, minus. Good. So, thinking. The basic concepts, just to recap here, processes and message passing. If you're not using processes and message passing, go back to Python or whatever. Don't try to use Erlang, Elixir, what have you, without embracing these things. You should be then using something that fits your brain and the domain you're in. Please remember this, and also be very helpful to the people that are not getting this point. Because once you break through this and you get to this one, you can start making wonderful architectures and things that actually works in the wild, like Sasha showed before me. It's important to do good stuff, to do this way. And the modeling of things is straightforward, mostly. I still have a few examples we can talk over beer where I don't know exactly what the natural process and message passing solution is, but with a bit of thinking it comes along. And that means that at all times, this is, if you need to have a tattoo one day, this is your tattoo. And this is what you should be thinking about. And if I call you at 3 AM in the morning, what are the pillars of Erlang, the divine intervention that came to Joe and the team? Fear nothing, fail fast, and failure handling. Forget one of them, and yeah, you know what, you deserve to die. So, thank you. Questions? Did I make you all hungry? That's good. Any questions? Yes. See if it works. Yes.
Torben, you could of course send over the complete program by Bluetooth. You don't have to send a command after each order. Would that be a simple solution, or?
Okay. That is actually what the Lego Mindstorms program environment does. So when you put all together all those blocks, they actually compile it into little commands, full programs there, and they send the whole thing over, and then it's executed. I would not like to write in that style, because that means that I'm not having access to processes, I don't have access to message passing. So the separation of concern I'm having here between the color sensor and the bumper would be like some sort of normal imperative general event loop and everything. So I just, yeah. But I could of course send over the entire Beam files to it, but that's what you do anyway when you copy over the source files and compile it on the thing. So that's not much of a difference there. But I think the cool thing is if you get into the mode of having the thing running on your computer, then you can mix in other things besides Lego Mindstorms. And then everything would be on the same paradigm. You're just sending messages out to things, and over Mindstorms it's a direct command to do something, and then some motors or things are doing something, or you read sensors, you put in a Raspberry Pi together with this thing, and you have the same concept. You just write a library in the same way. So your control program becomes the same, you're just plugging in different libraries to connect different environments into your system. So that's where I would go. Yeah.
We have time for a couple more questions, and then we're having lunch. Anyone else? Cool. All right. Lunch. So we'll be back in here at 1 o'clock.